So hi everyone, this video is about my own summary for chapter 6. And this chapter is about the network layer. So watch this. So this chapter is about the network layer. A network layer provides services to allow devices to exchange data across the network. It is located in the layer 3 of the OSI model. It uses four basic processes to accomplish the end-to-end transport. These are the addressing end devices, encapsulation, routing, and the encapsulation. The protocols of the OSI model network layer specify an addressing and processes that enable transport layer data to be packaged and transported. The network layer encapsulation enables data to be passed to a destination within a network or on another network with minimum overhead. There are only two common network layer protocol that is implemented, which is the Internet Protocol version 4 and or it is also known as the IPv4, and also the Internet Protocol version 6 are also known as the IPv6. The process of encapsulating data layer by layer enables the services and the different layers to develop and scale without affecting the other layers. An Internet protocol was designed as a protocol with low overhead that provides only the functions that are necessary to deliver a packet from a source to a destination over an interconnected system of networks. An IP has a characteristic which are defined as the connectionless, best effort, and media independent. Connectionless has no dedicated end-to-end connection to be created before data is sent. It will send a packet even if the destination host is not able to receive it. This process greatly reduces the overhead of IP. Best effort is where the packet delivery is not guaranteed. It is an unreliable because IP does not have the capability to manage and recover from undelivered or corrupt packets. Media independent. It is media independent will adjust the size of the packet sent depending on what type of network access will be used. IP operates independently of the media that carry the data at lower layers of the protocol stack. One major characteristic of the media that the network layer considers is the maximum size of the protocol data unit or the PDU that each medium can transport is the maximum transmission unit or DMTU. The data link layer passes the MTU value up to the network layer, then it determines how large packets can be. An IPv4 packet header consists of fields containing important information about the packet. There are significant fields in the IPv4 header that includes version, differentiated services or DIFServ or the DS, time to live or the TTL, the protocol, the source IPv4 address, and the destination IPv4 address. So a version contains a 4-bit binary value that is set to 0100, while the diff serve or the DS is formerly called as the type of service or also known as the TOS. It is the 8-bit field that used to determine the priority of each packet and what is the first needed the most. It has 6 most significant bits, which is the DSCP or the Differentiated Services Code Point, and the last 2 bits are the Explicit Congestion Notification or the ECN bits. The TTL or the time to live is used to identify how long the packets live. It limits the lifetime of the packet and it contains 8-bit binary value. A protocol field is used to identify the next level protocol. This 8-bit binary value indicates the data payload type that the packet is carrying. So it has common values, which are the ICMP or the Internet Control Message Protocol, the TCP or the Transmission Control Protocol, and the UDP. A payload can be captured and get by other. So IPv4 has been updated to address new challenges. However, even with changes, the IPv4 still has 3 major issues. These are the IP address depletion, internet routing table expansion, and the lack of end-to-end connectivity. So IP address depletion is where an IPv4 routes consume a great deal of memory and processor resources on internet routers. And a lack of an end-to-end connectivity is network address translation or the NAT is a technology commonly implemented within the IPv4 networks. NAT or the network address translation, it provides a way for multiple devices to share a single public IPv4 address. About the issues with the IPv4, it began to look for a replacement that led to the development of IP version 6 or the IPv6. It overcomes the limitations of the IPv4 and is a powerful enhancement with features that better suit current and foreseeable network demands. It provides the increased address space, which is the IPv6 contains a 128-bit that is equal to 340 undecillion addresses, while the IPv4 only contains 32-bit that is equal to only 4 billion unique addresses. One of the major design improvements of the IPv6 over the IPv4 is the simplified IPv6 header. The simplified IPv6 header consists of 40 octets, which is large due to the length of the source and destination of IPv6 addresses, and it has 8 header fields, which has 3 IPv4 basic header fields and 5 additional header fields. An IPv6 packet may also contain extension headers or EH, which provide optional network layer information. And another role of the network layer is to direct packets between hosts. A host can send a packet to a local host, remote host, and to itself. Remote hosts are devices that are beyond the local network segment. The router connected to the local network segment is referred to as the default gateway. It is the network device that can route traffic to other networks. The routing table of a router can store information about directly connected routes, remote routes, and default route. A router typically has multiple interfaces configured. The routing table stores information about both directly connected networks and remote networks. Packets cannot be forwarded by the router without a route for the destination network in the routing table. The default route could be manually configured or dynamically obtained. Cisco routers are designed to address the needs of many different types of businesses and networks, such as branch one service provider. Regardless of their function, size, or complexity, all router models are essentially computers. A router also needs a central processing unit or the CPU, an operating system or the OS, and the memory consists of RAM, ROM, and VRAM, and also flash. So RAM is a random access memory, while the ROM is the read-only memory, and the NVRAM is the non-volatile random access memory. So the connections on a Cisco router can be grouped into two categories: in-band router interfaces and management ports. There are three major phases to the boot up process. First, perform the POST and load the bootstrap program. Next, locate and load the Cisco iOS software. And lastly is to locate and load the startup configuration file on or enter the setup mode. In network layer protocols, forward transport layer PDUs between hosts. The transport layer adds a header so segments can be reassembled at the destination. IP is a media independent where IP packets can travel over different media. The two most commonly referenced fields are the source and the destination IP addresses. So these fields identify where the packet is coming from and where it is going. There are several different types and models of routers, but every router has the same general hardware components. Cisco routers and Cisco switches have many similarities, which they support a similar operating system, similar command structures, and support many of the same commands. The default gateway address is typically configured on all devices that wish to communicate beyond just their local network. To remotely access the switch from another network using the SSH or the secure shell or the telnet, the switch must have an SBI or the switch virtual interface with an IPv4 address, subnet mask, and default gateway address configured. So thank you for watching this, guys. So I hope you enjoy and understand my video, and I hope you learn also. So I'm Kisha Lyka Villanueva of IT 2105.